All right, guys, let's go ahead and review domain restriction. It's section 1.4. It covers worksheet 4 that we covered on Tuesday of last week. And I'm going to do examples 3, 5, and 11 from your worksheet 4, covering domain restriction, just to review one more time. Okay, so let's get ahead here. All right, so let me go ahead and start with example 3. So number 3 says, gives us a function, number 3 gives us a function, f of x equals negative x squared. And it asks us to evaluate at f of 1, x equals 1. They ask us to evaluate what happened there. And it says graph f of x if x is greater than or equal to 1. Let me check here if that's what it says. Yep, okay, greater or equal to 1. All right, so that's what it's asking us. Let's get started. The first thing I do before I even start graphing, I decide, okay, first thing I do is I identify what type of function do I have here. Okay, what kind of function do I have here? What is it going to look like? It is good to have a vision of what it's going to look like before you even start. So knowing that it's an x squared, I know this is going to be a parabola. Okay, and in parabolas we look for vertex and we look for a stretch. The stretch is the number, the leading coefficient right in front of the x squared that tells me which way I'm going, open it up, and this is a negative one, so this parabola is going to open down. So I already, okay, it's holiday, Monday, but apparently the bells still rings here. All right, so I see a negative 1 here in front of my x squared, so I know this parabola opens down. So it's going to look something like this, okay? But because this is restricted, it only wants me to graph this function for x's that are greater than or equal to 1. So the second thing I do is I evaluate. The second thing I do after I have an idea of what I'm graphing is I evaluate the function, I evaluate f of x at the critical point. Okay, at the critical point, in this case, the critical point, my restriction, is x is equal to 1. Okay, there's a restriction right here, greater or equal to 1. So I'm going to evaluate x equals 1. All right, so let's go over here and see what happens at x equals 1. If I plug in 1 for x, oh, I'm sorry, it was up there. So what happens if I plug in 1 for x? I still have the negative 1, invisible 1 in the front, times, now I have a 1 squared instead of x, okay? So 1 squared is 1 times my negative 1 that was there the whole time. We end up getting a negative 1. So when we plugged in a 1 for x, we got a negative 1 for y. And that is a very, very important piece of information. I'm going to put a little star because that is my restriction that the domain has it here, okay? So if I come to my graph over here, that's nice, create a graph here. Let's put 1, 2, 3. Let's label this corner over here, goes to positive infinity. Let's label over here negative 1, negative 2. I'm not going to go too far because I'm really not interested in anything in this direction. But let's label negative infinity here. Let's label all the 4 corners here. This is going to positive infinity. And over here is going to negative infinity. Here's 1, here's 2. Going down here is negative 1, negative 2, negative 3, and so forth. Okay? All right, so when I plugged in a 1 for x, I got a negative 1 for y. So that's my very first point right there. The reason why I'm putting a closed dot is because my domain restriction says equals 1. So I want all the x's that are greater or equal to 1. So includes the 1. So here's my closed dot. I want to be graphing my function, my parabola, but only for x's that are greater than 1. So anything that's greater than 1 in this direction to positive infinity should be part of my graph here. Nothing less than -1, because that's my restriction. So it's kind of like a boundary right here. I cannot graph anything less than just above. So if I want to graph this, I need at least one more point. I know that it's supposed to look like a parabola, but what part of the parabola? So why don't I plug in a 2? Why don't I evaluate a function at 2 or even at 3? Why don't we do this here on the side just to have an idea what direction am I going? So f of x, instead of x, let's evaluate at a 2. Let's see what happens when I plug in a 2. -1, because that's my leading coefficient here, times my 2 squared. -1, 2 squared is 4. So -1 times 4, and we get -4. So it looks like we plugged in a 2 for x, which is part of our domain, and we got a -4 for y. So 2 comma -4, somewhere down here, right there. And if I keep on going, guys, you will see that if I plug in a 3, I'll get a -9. And this function is going to keep going down lower here on the negative infinity. So now I can connect my dots and know that that's the direction I'm going right here. And there's the piece of my parabola, okay? If you use your previous knowledge, you would look at this and say the vertex is 0, 0. There is no h or k after this axis. So I know the vertex would have been here, okay? If I was graphing, it would have been here, and I would have gone down here on both sides forever. But I'm not interested in the entire parabola. I'm only interested in x's that are greater than 1. There's a restriction right here. I only want to see this portion of the parabola, okay? And that's one example of domain restriction, graphing domain restricted functions, okay? That's what number 3 looks like. Let's do number 4. Let me flip this page here. Let's use the same paper, save some trees. Let's go ahead and do number 5. So number 5 says f of x equals -4. So let's make a little note for ourselves here. Remember something from Algebra 1 or Math 1. Anytime we have y equals a constant, an integer, such as y equals 5, okay, y equals -2, y equals 0, any integer, any constant, that kind of function is called a constant function. And it will always look like a horizontal linear, like that. Okay, no matter what number it is, it's always, you know, y equals a constant. It will always look that way. If we have something like x equals a constant, like x equals 1, x equals -1, or x equals 3, or whatever, any type of integer, that kind of function, well, this is not a function, but this kind of graph will look vertically. It's a vertical line. So those are one of the things we covered in Math 1 or Algebra 1 many times. Of course, we forgot about it, but that's the two kind of functions, kind of graphs. I'm abusing math here by calling this a function. But these are the kind of graphs that we need to have it in our toolbox, something memorized. So when I look at this, I immediately remember that this is one of these functions right here. Remember, f of x and y are used interchangeably. They mean the same thing. So this is nothing but y equals -4 would be a horizontal line like that. But then there's a restriction. It says graph f of x, but only if you are using x's that are in between 0, all the x's values between 0, not including 0, and 6, including 6. The equal means include 6. So I'm going to be graphing this horizontal line that would have gone forever, but you restricted me. You said you only want it, this domain restriction says I only want it from 0 to 6. So here I go. Here's my x-axis and my y-axis. Here we're going to positive infinity. Here's a 1, 2, 3, 4, 5, 6, forever to positive infinity. Here, 0, -1,